This is about collision theory. Collision theory is basically the theory of why reactions happen, and it's to do with particles colliding. The particles can be compounds, molecules, or atoms, which basically means you can have maybe molecules of hydrogen colliding with each other, which would be H2s colliding with each other, or you could have atoms just colliding with one another on their own, not in a molecule pair. Okay, so reactions occur when particles hit each other or collide with enough energy. So you can imagine this as a kind of, if you were going to collide with someone else in a car, for example, you might collide with 5 people and no explosion would happen. But if you collide with someone very quickly, then an explosion is more likely. And the more people you collide with, the more likely it is for one of them to cause an explosion. So that's exactly the same with particles. The more particles that collide, the more likely it is for one of them to react with the other. And the faster they go, the more likely it is they'll react as well. Okay, so you use the word energy when answering questions in exams because it relates more to speed, but in a chemical way. And energy is also what's needed for the reaction to happen. And later on we'll go over exothermic and endothermic reactions, which also use this term of energy rather than speed. So, energy increases with increasing temperature. Hot particles move faster, and because they move faster, they're more likely to collide, and because they're more likely to collide, one of those collisions is likely to cause a reaction. Okay, so that's one way you can increase the reactivity speed or the reaction speed. Another way is to increase the concentration of particles. You can only increase the concentration of particles if it's a solution, so if the things are in aqueous state, or if they're in a gas. You can't do it in a solid because a solid is already joined in very kind of rigid ways, and there isn't much space between the particles already. But you can with a gas because gases are spread out. Okay, so the higher concentration in a gas wouldn't actually be called concentration though, it would be called pressure, because you're simply putting everything into a smaller box. So a box like that would be at a higher concentration or pressure than a box like this, just simply because the particles would be able to bounce all around here and they'd be less likely to hit each other in a bigger box. Okay, so that is just to do with space. Okay, so more space means less likelihood of them colliding. Less space means they're all squeezed into a smaller box and they're more likely to hit. Okay, so it's also the same with solutions because solutions are basically particles that are mixed into or dissolved into a solvent. Okay, so the solvent is the thing you dissolve the things into, and the solute is the dissolved stuff, so the dissolved particles. Okay, so an example is if you dissolve twice as much sodium chloride, which is this, into H2O, then you have twice as much space that's taken up by sodium chloride. So you can imagine that from, if you look at this diagram. So right now we have 2 sodium chlorides in a box. We can call this area in between the solution, okay? The white area is the solution. So if we add more sodium chloride, then each sodium chloride suddenly has a lot less space, okay? That's double the original amount. We originally had 2, now there are 4. So they take up double the amount of space in the box. So as they're colliding randomly in every direction, or bumping into the walls of the container, they're more likely to bounce back and hit each other, just because there's not much space left. So this shows you that in aqueous form and in gas form, you can increase the concentration or the pressure. And that basically leaves the particles less space, which makes them more likely to hit each other. And the more times things hit each other, the more likely they are to eventually react with enough energy. Okay, so another way is increase the surface area of the particles themselves. So if I go back to the picture, then you'll see that you can also increase the kind of pressure or concentration just by simply breaking up a really big clump of particles. We could call this a huge clump of maybe, well, for the sake we'll just call it particle X, which is nothing, doesn't exist. But if we break that up into many particles of particle X, well, it will still be particles, but they won't be joined together. Then we can see that there's way more chance of these hitting each other. And let's say there's another particle in there, particle Y. So the only way particle Y is going to react with X is if it hits this huge clump on the left. But on the right, it can hit maybe 4 times as many. So it can't just rely on hitting one lump, but it relies on hitting one of 5 lumps of particle Y. Okay, so if you think about that, that's actually the same as saying there's less space for each particle. Here, there's a lot of space for each particle because there are 2 particles, so you're dividing the space between 2 particles. Here, you're dividing the space between 6 particles, 5 particles of X and 1 particle of Y. So they will have less between them for each particle. Okay. So, the next way you can increase reaction rates is use a catalyst. Now, catalysts actually can cause more collisions to happen, and that's because if you're using a solid state catalyst, the atoms of the 2 reactants, or the 2 things reacting, actually stick to the surface of the catalyst, and so they are actually in a smaller space. They're stuck in a smaller space. And here we are. They stick to it. Okay. So that means that basically they're all in one area, one smaller area. So there are more collisions, a greater number of collisions, and this is actually very practical for businesses because catalysts increase the reaction rate, and you only have to buy one catalyst to make one reaction faster. So this is good because they then don't have to pay for pumps to increase the pressure if they're reacting gases, or heaters to increase the temperature of particles. Now, pressure and heating is actually a good way of increasing the reaction speed, but it can get expensive if done in the long term. So catalysts are good because they only have to be purchased once, while with pressure and heating you have to pay per unit, just like you would in your house when you're heating your house. So the positives and negatives of catalysts are down here. So first of all, we have they are never used up. So they're never used up, which means you only have to buy one of them for each reaction. Okay, but they are expensive. So the first time you buy it, it'll be expensive to buy. And they need removing after the reaction. This is because, if you think about it, the particles are actually sticking to the catalyst when the reaction happens. So after the reaction happens, the particles will have combined or reacted and formed new compounds of molecules or particles, and they will still be stuck to the catalyst. But you don't want to sell your customers the catalyst and the product, you just want to sell them the product. So you do need to remove it. So it needs removing after the reaction, since it's mixed into the product. Okay, they are specific to certain reactions, which means you can't use one catalyst to react oxygen and carbon and then the same catalyst to react hydrogen and oxygen, for example. Now, that means that you'd need to buy 2 catalysts if you were doing 2 reactions. And if you were doing 100 reactions, you'd probably have to buy 100 different catalysts. Okay, so you can see that that would be expensive. Theoretically, very expensive. So catalysts can also be poisoned, which means they will react well with the reactants they're supposed to react with, but if you put anything else in there, then they will get poisoned by that impurity. And impurities are just anything that shouldn't be reacting on the surface of the catalyst. So they might not be poisons that we think of, but they might just be any atom that isn't supposed to react with it. Okay,